Hello, good morning. This is Farhan Khan from the Republic 2.0, and today's topic is from the Unit 1 Mechanics, and that is adding forces. So today we are going to learn that how can we vectorially add two or more forces, right? There are some different rules, and we are going to talk about those rules. So adding forces, first of all, we'll be talking about those forces which are basically, acting parallel to each other. So the first case in addition of forces are the forces which are acting in the same line. We'll be talking about the forces which are acting in the same line, right? How do we add these forces? So basically, we just need to, for example, we've got force 1, this is F1, and another force. The magnitude of F1 is going to be 5 Newton, and there is another force whose magnitude is 3 Newton, and that is F2. So now we just need to draw a single vector in the same direction, but the magnitude of that single vector is going to be 8 Newton. So whenever you want to add forces which are acting in the same line, this is how we add them up. Now, for example, somebody tells us to not get ourselves F1 plus F2. But what we're going to do now, we need to get ourselves F1 minus F2. So first of all, F1 minus F2 is the same thing as it was F1 plus F2. The only thing that we're going to do is just add the negative of F2 into F1. So F1, I'm going to draw F1 as it is. The magnitude would still be 5 Newton, and that is going to be F1. But when I'm going to draw negative F2, what does that mean? That I have to draw the same vector, but in the opposite direction. That would make it negative F2. So F2 would be still 3 Newton, but with a negative sign. And now since we need to add them up, F1 minus F1 plus minus F2, what I'm going to do, I'm just going to draw a single vector in the direction of 5 Newton, whose magnitude is going to be 2 Newtons. So that is how we add forces when they are acting along the same straight line, right? So this is how we're going to do them. Now the next thing is, we have to add two or more vectorial forces when they're acting perpendicular to each other. So we do not need to do anything. We just need to connect them in order. So second case is that we are going to add forces acting perpendicular adding perpendicular to each other, right? So how are we going to add them up now? For example, if we're having a vector, which is, for example, F1, something like that, and then there is another vector which is acting in a direction perpendicular to F1, which is F2, and since we need to add them up, for example, the magnitude of F1 is going to be 3 Newtons, and the magnitude of F2 is going to be 5 Newtons. So when you're going to add them up, you just need to connect them together. This is going to be F1, and what I'm just going to do, I'm just going to grab this vector, this whole of the vector, and I'm going to place it right at the head of F1. So that is going to be F2. So this is F2 and this is F1. F1 was basically 3 Newtons. F2 was basically 5 Newtons. And now since we're going to add them up, so the resultant vector should be towards the head of the last vector. That is the very important thing. This is going towards the head of the last vector. So that is going to be the resultant vector. Now, the next important thing is that how would you determine the magnitude of the resultant vector? Trigonometry helps us with the direction, but how are we going to calculate the magnitude of R? So what I'm going to do, R, since that is the hypotenuse of this right angle triangle, so we just need to take the square root of the sum of the squares of other two forces. So F1 square plus F2 square going to give me the final answer, and that should be, the square of F1 going to be 9, the square of F2 going to be 25. I'm just going to add them up, so I'll be having 34. So the magnitude of the resultant vector is going to be 34 newtons. So this is how we add forces when they are acting perpendicular to each other, something like that, right? We've got one vector f1, we've got another vector f2. We just need to connect them like that, and then we'll get the resultant. So this is how we add two vectors which are perpendicular to each other. Now, the last case of these things, the last case is that how are we going to add two non-perpendicular vectors? How are we going to add non-perpendicular vectors? Now, there is a specified rule for that. How do we add adding two non-perpendicular vectors? And what is that specified rule? The specified rule about adding non-perpendicular vector is known as a parallelogram rule. That rule is known as a parallelogram rule. What do we do in a parallelogram? For example, we are having two vectors which are not perpendicular to each other. For example, one of them is like that. This is F1, and the other one of them is something like that. This is going to be F2. You just need to connect them at their initial starting points. So what I'm going to do, I'm just going to connect them at their initial starting point. This is F1 and this is F2. Now I'm going to draw two more vectors such that they would be creating a parallelogram. So this is F1. I'm copying F1 over here as well. And then there comes an F2, right? So this is F1 and this is F2. So this is how we just simply add them up like that. And now the resultant vector would be the diagonal of this parallelogram, something like that. Okay, so this is going to be the R. So that is how we add two non-perpendicular vectors by using a parallelogram. We just connect F1 and F2 at their origins, and then we complete the diagram to make up a parallelogram, and the diagonal of that parallelogram is going to be the resultant. Now, the very important thing, how do you get the resultant's magnitude? So you have to use a formula, which I'm going to write over here, that the resultant would be equal to F1 square plus F2 square minus 2F1 F2